All right, let's dive right in. Today, we're talking about something pretty incredible. Artificial intelligence that doesn't just live on a server somewhere, but actually gets its hands dirty in the real world. We're going inside the mechanical and AI lab at Carnegie Mellon to see how they're teaching AI not just to think, but to literally build the world around us.
So, let's start with a big question. One that really gets to the heart of all this. What if AI could truly interact with the world? I'm not just talking about processing data. I mean seeing, feeling through sensors, and physically building things. That's not science fiction. That's the future they're engineering right now.
So, how in the world do you even start to do that? Well, the very first step is tackling the core challenge, teaching AI about the physical world itself. And that is the exact mission of the Mechanical and AI Lab, or MAIL. You see, the real world is messy. It's governed by these super complex forces that are chaotic and unpredictable. Think about how water flows or how heat spreads. Our old models just can't keep up. So what MAIL is doing is bridging that gap, merging the world of data science with the fundamental laws of mechanical engineering.
Okay, so we've got the concept down. Now let's see what it looks like in action. Starting with our first major application, using this new breed of AI to manage the huge complex systems that make our world run.
You know, with sensors and the Internet of Things everywhere, you'd think we have all the data we need. But here's the catch. We're drowning in information, but a lot of it has holes. It's sparse, it's noisy, it's incomplete. So how can you possibly make a good decision about, say, a city's power grid when you can't even see the whole picture?
And this is where the AI solution is just brilliant. The lab is creating brand new algorithms that are designed to learn from less. It's like being able to see the whole picture, even when you only have a few puzzle pieces. They can take that patchy data and make incredibly accurate predictions, filling in the blanks for us. And that's the key, right? This lets us build stronger infrastructure, smarter cities, and safer self-driving cars, all by getting smarter with the data we already have. Okay, this next part is all about speed. What if we could invent the materials of the future and then manufacture them perfectly whenever we wanted?
Just look at the difference here. The old way of finding a new material for a better battery or a medical implant is just a slog. It's slow, it's expensive, it's tons of trial and error. MAIL's AI method just flips the whole script. It's like having a super intelligent navigator that searches a massive universe of possibilities and points right to the most promising options. This cuts down the time and cost of discovery like you wouldn't believe. And this is so cool because it shows how AI is changing not just what we make, but how we make it. Take 3D printing. These AI systems act like a master craftsperson with superhuman senses. It's watching the printing process with computer vision, spotting microscopic flaws, tiny holes or gaps the instant they appear, and then corrects the machine on the fly. It can even predict how good the final part will be before it's even done printing.
Now, a key piece of the secret sauce here is something called physics-informed neural networks, or PINs. The best way to think about it is this. You're not just showing the AI a bunch of examples. You're basically making it go to school and study the textbook on the laws of physics. That way, its predictions aren't just based on patterns it's seen. They're grounded in the reality of how the world actually works. That makes them way more accurate and trustworthy. So, we've gone from smarter materials to smarter machines. This next section is all about evolving robots from these rigid, pre-programmed things into agents that are truly intelligent and can adapt to new situations.
The trouble with most robots today is that they're amazing, but only in their perfect little bubble. In a controlled factory doing the same thing over and over, they're champs. But the second you introduce a little bit of real-world messiness and uncertainty, they completely fall apart.
So the answer's pretty obvious, right? You have to teach them how to learn, just like we do. The lab is using these incredible AI models that let a robot just watch a task being done, and it gets it. Then they learn through trial and error, getting better and better over time. And maybe most importantly, they're learning to combine their senses. And that brings us to this key idea: visual tactile sensing. It sounds like a mouthful, but it's something you do every single second. It's just combining sight and touch. When you pick up a cup of coffee, you don't just look at it. You feel its weight, its texture, its warmth. Giving robots this combined sense lets them handle the world with so much more skill and precision.
And this is really the ultimate vision. This quote from the lab just says it all. The goal is to create robots that can actually reason, perceive their surroundings, and act with a genuine sense of purpose. It's about closing that gap between a simple machine and something that thinks.
All right, for our final area of research, we're diving into something that has maybe the most direct impact on our lives, using AI to untangle the mind-boggling complexity of biology and human health.
And listen, if you thought mechanical engineering was complex, biological systems are on a whole other level. The way proteins fold and dance around and interact with molecules, it's this incredibly complicated ballet that's almost impossible to predict with old methods. This table right here, this shows an absolute game changer. For decades, to figure out if a new drug might work, scientists needed the exact 3D structure of a protein. That's super hard and takes forever to get. What Mail has built is an AI model that can predict if they'll stick together using just the simple sequence of the protein in the drug. This is a massive, massive leap forward.
So what does this actually mean for us? Well, the impact is enormous. It makes the very first steps of finding new medicines way faster, way cheaper, and available to way more scientists. It's creating this whole new highway for what's called in silico drug discovery, which basically means finding new drugs entirely on a computer.
Okay, so after looking at all these different pieces, smart cities, new materials, adaptive robots, faster medicines, what does it all add up to? Let's zoom out and look at the blueprint for tomorrow this research is building. What we've really seen is this single, powerful vision where AI is shaping our physical world. It's giving us smarter cities. It's helping us discover incredible new materials at lightning speed. It's building robots that can learn and see the world. And it's decoding biology to bring us life-saving medicines faster. And that leaves us with one final, and maybe the most important question of all. This technology is incredibly powerful. As we teach AI how to design and build and interact with our world, we have to remember that we are the ones designing the AI. So the real question for our future isn't just what AI can do for us, but how we choose to guide it.